Hi there, this is Susan Norrell, and I thought that I would try to make a short video on plotting rational numbers on a number line. I know that a few people are having trouble with this particular topic. So what I want to start with is looking here at the -1 and 5/6. So basically what we're doing is we're starting here at -1 and we're headed towards the -2, 5 out of 6 spaces there. So 1, 2, 3, 4, 5, 6. So what you've got here is you've got -1 and 5, 6. So that's going to put you close to that -2. So if it's negative, you're going to go towards the negative direction. If it's positive, you're going to go towards the positive direction. So let's look at the positive one here, 7/3 is just a division problem. This is 7 divided by 3. So let's think. 3 will go into 7 2 times, because 2 times 3 is 6. And then if I subtract here and get a remainder, my mixed number that I'm looking at here is going to be 2 wholes, and my remainder over the original denominator of 3, because we're talking about thirds. Now, what I want you to notice here, so what I've done here is I've changed 7/3 to 2 1/3. So we've taken the 7/3, we've changed it to 2 1/3. But, no, and because it's positive, we're going to be headed in the positive direction on the number line. But you'll notice here that my lines are broken up into 6. So it's kind of like, well, where are the sixths then, or where's the 1/3 if I'm broken up into 6? So what I tend to do is I tend to take that fraction 1/3, and I want to multiply that 3 by something that will give me a 6. I want a denominator of 6. So what do I need to multiply 3 by to get 6? I need to multiply it by 2. But if I multiply the denominator by 2, then I also need to multiply the numerator by 2 in order to keep the same value of this answer. Because to multiply by 1 is not to change its value, it's to change its appearance. Or as I used to tell my junior high student, its outfit. So here I would have anything times 1 is still itself. So 2 1/3 times 1 here would give me 1 times 2 would give me a numerator of 2. So 2 1/3 becomes 2 2/6. And that will simplify. 2/6 will simplify to 1/3 if we just take, just to kind of show you here. If I were to divide 6 by 2 in order to get that denominator of 3 again, then I would have to do the same thing to the numerator. I'm sorry, that should be a 2, not a 3. So 2 divided by 2 is 1. So you can see again that we can change 2 2/6 back to 2 1/3. So now that we have 2 1/6, let's go back to our original color here. Let's go positive 2 and 1 of the 6 values. I'm sorry, 2/6. 2 and 2/6. 2 wholes, 1, 2, 6. And that would be the same thing as 2 and 1/3. So basically what I'm doing here is I'm just changing the fraction itself to have that denominator of 6. Alright, so let's try another one. If you want to pause the video and try this one on your own, try to go in the negative direction 2 1/2 and in the positive direction 3 1/4. Alright, if I'm going to go negative 2 1/2, well, obviously you can probably see that here is negative 2, so negative 2 1/2 is going to be in this area here. So here I'm going to take that. Notice it's split up into fourths. 1, 2, 3, 4. So if I take 1/2 and I want it to have a denominator of 4, what do I need to multiply 2 by to get that 4? Well, I need to multiply 2 by 2 to get 4. So that means I also have to multiply the numerator by 2. So 1 times 2 would then give me 2/4. So that's why here this would be like 1/4, 2 and 1/4, 2 and 2/4. So that's putting that at that negative 2 1/2. Okay. If we now want to try the 1 3/4, that's going to be a little easier because of the fact that first of all, I'm going to go in the positive direction, positive 1, 1, 2, 3 out of 4. So that one was much easier because I didn't need to convert anything. Alright, now let's try this one again. If you want to pause the video, try this one out on your own. Remember, the negative 3/4 is going to go in this direction. The positive 9/4 is going to go in the positive direction. So let's try negative 1/4, negative 2/4, negative 3/4. Notice that's putting me there in front of negative 1. I don't have a mixed number, it's just a fraction itself, so that's before the negative 1. Alright, so now let's try the 9/4. Remember, 9/4 is just going to be a division problem. 9 divided by 4. 4 will go into 9 2 whole times. So I'm looking at a whole number of 2. 2 times 4 is 8. So if I subtract that, that gives me a remainder of 1. So the 1 is the numerator. The remainder is the numerator. And we keep the same denominator of 4 because we're still talking about fourths here. So 2 1/4. Here's positive 1, positive 2, 1 out of 4. So there would give me that 2 1/4. Now another way you could look at this is 9/4. So starting here at 0, if I go 1, 2, 3, 4/4, 5, 6, 7, 8/4 would be 2 wholes, and then 9/4. Since the number line is already cut into fourths, you could just count 9/4 into the positives. So that's another way to look at that. Alright, see if you can try this next one on your own. This one's going to take some converting, but this one won't. So try this next one. Pause the video. Alright, so here we're going to go -1, -2, and 1, 2, 3, 4, 5, 6. So here would be -2 and 5, 6. It's putting me close to that -3. Sorry, that was my grandson. Alright, now let's go to that positive 1/3. Positive 1 1/3. If I want to change that 1/3 to 6, because my number line is broken up into 6 pieces. 1, 2, 3, 4, 5, 6, 6. So if I want to change that 1/3 to a denominator of 6, think about, what do you have to multiply 3 by to get 6? Well, I have to multiply it by 2 to get 6. So if I do the same thing to the numerator, 1 times 2 would give me 2/6. And again, basically what that is I'm taking 1/3 times 2/2. So I'm not changing its value, I'm changing its appearance. By multiplying it by 1 whole, I don't change its value. And then again, that would give me that 2/6 that I need. So this 1 1/3 is actually going to become 1 2/6 on my number line. So if you want to pause now and see if you can find that on the number line. Okay, we have positive 1, 1/6, 2/6. So there would be 1 2/6, or 1 1/3. And you can kind of see how you can break that number line up into thirds. Another 2 spaces would be another third. So basically what we have here is we have 1 1/3, 1 2/3, and then 2 wholes. So that's kind of how you can see, you can break the number line up into thirds as opposed to just 6. Of course, that's not part of our answer, so I'll remove that so I don't confuse you. Alright, one final one, and then hopefully you'll have a little bit easier concept on this. So -2 3/4 is going to be pretty easy for us. Go to the -2, -2 1/4, -2 2/4, -2 3/4. So there's that first one. And then for the second one here, if I think of this in halves, we have here, let's label this into halves. So here would be 1/2, 2 halves would be 1 whole, 3 halves would be like 1 1/2. 4 halves would be 2 wholes, because 2 will go into 4 2 whole times. And then 5 halves would be over here. So you could count it in halves. 1 half, 2 halves, 3 halves, 4 halves, 5 halves. Or we could change that to, we could change 5 halves to a mixed number by saying 5 divided by 2. 2 will go into 5 2 whole times. Remember, this fraction bar is just a division sign, so 5 divided by 2. 2 times 2 would give me 4 here, and a remainder of 1. So that would be 2 wholes and 1/2. And since it's broken up into fourths, I can take that 1/2. I need a denominator of 4. So 2 times 2 gives me 4. So multiply the numerator by 2 as well. 1 times 2 is 2. So that would be 2 wholes and then 2/4, which is basically what I've got here. I have 2 wholes and then 1 2/4. So that still puts me right there at that same location. Alright, I hope this video was helpful. Please let me know if you've got any questions on plotting rational numbers on a number line.